Hello guys, welcome back to the channel for a new Databricks video. Today's video is about how to clone a delta table in Databricks. We have two distinct ways to do that. We have deep cloning and shallow cloning. Each method offers a different behavior in terms of data duplication, performance, and how subsequent actions and operations affect the tables. Now, when you use deep cloning, then you create an exact copy of the original table in a new location. You copy the metadata and the data. On the other hand, when you use shallow cloning, you only copy the metadata in a new location, but you are still referencing the old data in the original table. So in general, you would say that you use deep cloning when you want to create backups and shallow cloning for development purposes. Let's see a practical example. Okay guys, here on our Databricks workspace, the first thing we have to create is a delta table, apparently. So we have a delta table with 3 columns, ID, name, age, and 2 records here. Let's select the data from this delta table. We have 2 records, yep. And now let's check the files on DBFS, on the Databricks file system. As you can see, like any normal delta table, it has the delta log folder with the metadata and the parquet files containing the data. Now let's move to shallow clone. A shallow clone of a delta table creates a new table, but it does not copy the data. Instead, it references the data files of the original table. This makes the cloning process very quick and storage efficient. Metadata is duplicated like schema and partitioning. Files are not duplicated, so the data is not duplicated. The new table points to the existing data files. Operations like append, delete or update on the cloned table will manifest as a new version files that will diverge from the original. Best usage for quickly creating a table for testing and development purposes, situations that require rapid duplication without additional storage overhead. So let's create a shallow copy of the original table. The syntax here is create or replace table, just provide a table name, and here you have to use shallow clone and then the original table name. Now, if we check, we can actually let's describe the delta table to see the DBFS location, and this is the DBFS location, right? And let's see the data. Let's select from the shallow cloned table, and we have the same data with the original table. Now the only difference is when we check the Databricks file system, you will see there are no parquet files as in the original table, because we only copied the delta log folder with the metadata, but we are still referencing the old data in the original table. And this is how that's the main thing about shallow cloning. You only copy the metadata. Now, if you insert a new record on the cloned table, in the shallow cloned table, what you are going to see here on DBFS is that we add the parquet files. Now, from this point onwards, when we insert update anything on the clone table, then we generate the parquet files on the new location, right? So here, now if we select the data, you will see we have this new record. However, the original table wasn't affected at all, apparently, because we inserted this record on the cloned table. Now, what happens if we insert or update records in the original table, right? So let's do that. Let's insert a new record and update an existing record in the original table. What is going to happen? Let's see the original table first. Now with the new data, as you can see, we have this, we insert a new record, we updated an existing one. However, the cloned table wasn't affected at all. The reason is that the clone table is still referencing the old version of the data in the original table. So that's how it works, right? So any changes in the original table won't affect the shallow cloned table. The only caveat here is when you use the vacuum command. So the vacuum command cleans up the old data files that they are no longer accessed by the table versions in storage. Running vacuum removes all the unreferenced files. So what happens sometimes when you use the vacuum command and you remove the referenced the old files, then the shallow clone can still if the shallow clone is still referencing those files, then you will get an error. If the shallow clone was depending on old files that got removed during the vacuum operation, attempting to access it can lead to errors such as missing file exceptions. Moving on, we have deep clone. Deep clone, in contrast, creates a complete copy of both the data and metadata of the original table. This is more storage intensive and takes longer, but allows the clone table to operate entirely independently of the original. Both metadata and data files are fully duplicated. The clone table is completely independent of the original table. Changes to one do not affect the other. Best for creating backups, situations requiring full table isolation for security or organizational purposes. How can you create a deep clone of the original table? Using the deep clone syntax here and pointing to the original table. Now, if you check the files on Databricks file system, here you will see that we have an exact copy of the original table with the parquet files and the delta log folder, etc., etc. And let's see the actual data, and you will see it's the last data that we updated, because it creates an exact copy of the original data, completely independent, and then you can perform whatever actions you want on the deep clone table without affecting anything else. This is it for today, guys. That's about shallow and deep cloning in Databricks. I hope you found this video useful. If you like the video, please click the like button, subscribe to the channel, leave a comment, and I will see you in the next one. Thank you.